Let's talk graph theory and connected versus disconnected graphs. So we have some terminology to talk through first. So first, a path. A path is a sequence of vertices connected by edges that begins and ends at the same vertex with no edge being repeated. Great. A connected graph just states that a path exists between any two vertices. All right, so we can make a path. A subgraph of a graph includes only some vertices and some edges of the whole graph, which kind of makes sense, right? If we have a set and a subset, same idea of a graph and a subgraph. A connected component is a maximal connected subgraph. Or what that really means is that we have a subgraph that is connected and is as large as possible. So if we have a connected graph, that means we have one single connected component. The whole graph is connected. Think about if you were going to draw in like from vertex to vertex, so vertex to vertex, you could draw the entire graph without picking up your pencil. Whereas a disconnected graph, or a graph that is not connected, there are two or more connected components, meaning if I was going to draw the whole graph, I would have to pick up my pencil to get to the other components. Let me show you that. So here's an example. Is the graph below connected, and how many connected components does it have? So we have points A through G, and if you think about, can I draw this thing without picking up my pencil? Well, if I just start at, let's say, point A, and I just start drawing, I can go through, and yeah, I can draw the whole thing without picking up my pencil. So yes, this is a connected graph. It has one connected component because it's all connected. Whereas in this particular graph, where we have three squares kind of embedded in each other, is the graph below connected? Well, if I start drawing, I start at point A, so the outside square is A, B, K, L, and if I draw those four, right, that's a connected component. But then to go to the next inside square, I have to pick up my pencil. So I start then at D, and I go D to point C to point J to point I back to D. That's the second one. And then E to F to G to H back to E. This has three connected components, and no, this is not connected. Because when I went to draw the entire graph, I had to pick up my pencil twice. So there are three connected components for this entire graph. And that's kind of how you can tell whether you have a connected or a disconnected graph.